Hi, folks. Let's see. I think you are 157. No, 210, 157. I trust you got the email that I shipped you. Anybody out there? So you got two. Why don't you write your name and type your name in so I can, three of you. Okay, two of you. Great. Type your name in. Excuse me, just get through a little bit of lunch. Hannah Reynolds. Good afternoon, Hannah. Riley Helms. I still had your notifications on and wanted to tell you to have a good summer. Well, thank you so much for that, Riley. I appreciate that. You got through there, didn't you? It was kind of tough trying to get all that stuff together after the virus took a swing at us and kicked us around a bit. That's great. I hope you have a good semester, Riley. Weren't you going into dental hygiene? I think you were going into dental hygiene, if I remember correctly. So maybe someday you'll be taking care of these pearly whites that I have. Thank you, Riley. Appreciate that. Hannah Reynolds. Yeah, here we go. Oh, how nice. That's great. So you'll start hygiene in January, whatever. You're going to have a lot of experience. If you're assisting in the fall, does that mean you're with a dentist? That's nice. Well, if you can do what you enjoy and make a living at it, that's a real nice blessing. There are a lot of people that go to work and don't like what they do. We'll give them a couple of more minutes to see if anybody else is going to join us. Maybe they'll read it tonight if they're working. That's one of the nice things about online instruction. All of you who have joined the teaching hour, I see we got 4 people there. If you would, just type your name in so I can get to know you a little bit. Keep a record of your presence. Okay, well, we'll go ahead and get started. I see one person's dropped off, and there's 3 of us now. I don't know if that includes me or somebody else out there. But anyway, Hannah, you're new to it. Riley suffered under my tutelage and did well. So she already knows me, but I'm Mr. Pritchett, and there should be in your D2L work, you should be able to see a syllabus. So you want to make sure you read that. It's going to explain to you about the testing, the grading, and so forth. And it's also got in there some information about honor lock. And so you need to, hello, Brandon. Let's see. Yep, there you are. Mr. Pritchett, glad to have you here. I assume you're in here for 210 and going to move into some field like radiology or physical therapy or nursing or maybe a PA, something like that. But glad to have you with us. But make sure you, when you get into D2L, you look at that syllabus, take your time and read through it. There's going to be a course schedule. Of course, this is the first week, and we will try to cover, we'll cover a little bit of chapter 1, and then we'll try to dig into chapter 2. There's just something I want to start with on page 21 of your textbook. If you have a textbook, so we got the course schedule. If you click under content, then you will find, if you haven't already used D2L, that's going to be where an e-text is, an electronic text is on every one of the D2L. Boy, it's saying my connection is unstable. I hope that's not going to be the case. Hope y'all still can see and hear me, mostly hear me. That's the important thing. And there's an honor lock statement in the syllabus. So you want to make sure you read that and follow whatever instructions that statement says. Some people have tried to run the test that we will give you, and that is proctored by Honor. Look, the other browsers, I guess you would say, other than Chrome, don't seem to be able to handle whatever Honor Locke is going to do. So make sure you do that, if you would. Well, let's go ahead and get into the textbook. A number of things that you're going to be tested on will also be in the lab. So as you learn the anatomical position, the anterior, posterior parts of the body, dorsal, ventral, lateral, and all those directional terms, your hand is distal to your elbow, and so forth. You'll also be tested on those whenever I give a test. Mr. Malachowski, who runs this, wants you to put the two together so that when you take the final exam, that final exam is going to be what they call a comprehensive final. So it'll have and lecture on there, somewhere around 125, 40 questions. And so make sure you're preparing yourself for that. There's also, I think, a mention in there about homework, and that's in the content area of D2L, and you can click on HW. You want to start on that already, because HW means your homework. And hello, Jay Sheen. And let's see. Jay Sheen. Destin McKenzie, right? Okay. So you make sure you get in there and do those homework assignments. You've got the book to look at. You've got the notes that I sent you. I hope you all got the email I sent you with the content that we're going to seek to cover. We won't get through it completely today, but anyway, if you do that homework, then, and you take time to do it, look through the book well and whatever notes, and you answer those questions that are asked of you, then you can end up with a bunch of hundreds. And so those would all be averaged together with your lecture exams. And that can be a very high grade if you spend the time to do that. Do not wait until the night before it's due on a Sunday. I think you've got something due probably this Sunday. So you want to make sure that you get that done. You can do several of them at one time if make that time frame available, and then you'll cut down your possibilities of procrastination and end up not being able to turn in one. If you don't turn in one, that's a 0. So it's required of you. So make sure that you get onto those homework sessions. You probably have a homework session on chapter tomorrow or whatever. Just don't lose that possibility of a good grade. Okay, on page 21 in your textbook, or if you have your online e-text, then you can look on what we would call Module 1.5. So there are a number of modules in each of the chapters. And this one, 1.5, is on page 21. And one thing I want you to do, I think that'll help you tremendously, is the nice organization here, is you see below the title, Core Principles in Anatomy and Physiology. And it says Learning Outcomes. This is what you want to be able to do. If you're not able to do that in the sense of carrying out the answer of the question, like describe the principles of homeostasis, well, if you can't do that, then you don't know much about homeostasis and how it's relative to the anatomy and the physiology of the body in which we live. So for those 6 there, you want to read those before you actually start reading this chapter. Obviously, we're going to go through this. We're going to cover some things, and you'll hear the answers to some of those. But can you imagine some of those learning outcomes could turn into exam questions? Those are great exam sessions. Describe the components of a feedback loop. We're going to talk about that today, see? So the more you can answer the learning outcomes, better off you're going to be. It's not going to be a cakewalk. It's a new life in terms of what most people have been thinking about. I don't know, Brandon, if you and Jason had Bio 110 before this, you may have come in with a good score and been able to take this without ever having any anatomy prior to this. But anyway, let's look at this second column now. Overall theme, physiological processes operate to maintain the body's homeostasis. Those physiological processes can also be called homeostatic mechanisms. And when we think of homeostasis, we think of keeping the internal structures, internal processes balanced. Homeostasis is talking about keeping it stable, keeping it balanced. And so this is really very critical to our health. One of the simple ones that we've talked about before, that you may have talked about before, one of those mechanisms is how do we keep our body temperature at the precise number that we're set for. Different people have different temperatures. Some are 98.6, some are 98.8, some are 96, a couple of degrees lower than the average person. That's why it's important, if you're a nurse and you have children, say you're a school nurse, and a little kid comes in, I don't feel good or whatever, and you take the temperature and it's 99 or whatever, or 100. Yeah, you got a little fever, but I think you could go back in or whatever. But if that kid's base number is 95 or 96, that kid's up there where like you and I would be at 103 and 104. And so that's a good thing to know. These kids might have a subnormal temp. That's normal for them. So thermoregulation is one of the homeostatic aspects that you'll be associated with all through 210, and I assume you're going to take 211 in the fall. So these mechanisms that work for us, they do a good job. It's all planned into our DNA. It's not some chance event. And we're thankful that the genes do that, because that frees us to go enjoy a concert as soon as we can stop social distancing for this virus. But it allows us to be free to do other things rather than be thinking about, oh, I need to up my temperature or drop my temperature or whatever. So those are, that's just an example of one. Now, if you look down at the bottom of that column on page 21, you see quick check. And that's something I also want you to look at and answer those questions. If you can answer them, why is it important? Why is homeostasis important? What is homeostatic imbalance? And when you can talk about that, that means you have a command of the information. That's Mr. Malachowski's goal. That's Mr. Davis's goal. That's Mr. Boggs, I believe it is doing the other. Maybe Ms. Watson. But that's what I want for you too. If you can't explain something, then you don't understand it. and we want to get you to the point of understanding something. I know you got to memorize. Nothing wrong with that. I started doing that when I was a senior in college. I was smart enough to get about a 2.6 as a freshman, sophomore, and a junior, and then I realized I need to get to work. It's called growing up. And I grew up and got on the dean's list and began to use my time judiciously. So please do that. So back down here on that column, always look at the quick checks as well as learning the outcomes. Go back and look after you finished some of the information, see if you can answer those questions. Now down there, core principle 1, concerning these physiological processes. And you see in there, in about the 3rd line down, you see feedback loops. Now, feedback sometimes can be bad if you're playing your musical instrument in front of your speaker and you can get some feedback, and not very pleasant. Feedback can be positive in the sense of encouraging a person. But if you look on page 22, you see says next negative feedback loop. And they give you F. And so you want to be able to give a definition of that feedback loop. The feedback loop consists of several components. As you look down to the bottom of page 22, you see in bold print in that last paragraph, you see 1, 2, 3, 4 bold print terms, and then there's one up top. You see another one. And so you want to know the components of a feedback loop. What structures make that loop up? The stimulus is what starts the ball rolling. That's usually something internal or external that is going to upset our balance. But you have a receptor or a sensor that picks up the stimulus. And let's say it's heat. Let's say that you're out getting some exercise and your body starts warming up. And of course, here in South Carolina with the humidity in the summer, it's easy to start warming up. So the stimulus would somehow attach to the receptor or stimulate the receptor. The receptor is going to transfer what it picked up, whatever, and that control center is going to send a message back through an effector. That's at the top of page 22. So that's pretty much the components, the receptor, the control center, and the effector. And of course, the effector produces a response. Now, when you think of a negative feedback loop, all of us have been exposed to that. And you can probably think of it when you were a child, and I can remember it as a child also, that sometimes we would get out of hand. There's a lot of ways to saying that we were becoming a nuisance or we were misbehaving or whatever. But our parents spoke to us. They were the receptor, and then they made a choice in their own minds. That's their control center. And then they either said something that caused us to change our behavior, or they applied some force that was necessary to get our attention. But the point is that our behavior was brought back to an acceptable type of behavior. So when you think of a negative feedback loop, the negative feedback loop is going to change the stimulus. It's going to respond to the stimulus so that you keep the body in balance. In the case of heat, like if you're jogging and the body gets hot, then the sensors pick that up, send it to the brain. The brain sends down to an effector, which in our case is going to be a sweat gland. and the sweat gland will produce the water. Unfortunately, in South Carolina, when it's humid, that water does not evaporate. Normally, in a drier climate, that water evaporates, and when it evaporates, it takes away the heat from the body. So the body was getting overheated, and this negative feedback loop, a homeostatic mechanism, sends a message back, starts sweating. If you're in Arizona, you hardly notice the heat. It might be 110 because it's so dry, and that sweat evaporates, and you don't even realize that you're hot, because you're not, because it's taking away the heat from you. So you want to be able to apply that to a number of situations in the body where you change the original condition that is causing a potential problem. They give you on the next page 23 a couple of examples that most of you have thought about. You can read about the radiant heat up there in the top half, and then the one down at the bottom where you're cold and your muscles shiver and generate heat, and therefore it warms your body up. Those are all negative feedback loops. There's a positive feedback loop down at the bottom of page 22. I want you to read about that. Positive feedback loop does exactly the opposite of a negative feedback loop. And one of the best known positive feedback loops is the contraction of the uterine muscle when it's time for birth. As the child grows, as the fetus grows in the uterus stretches, and eventually at a certain point it begins to resist the stretching, and it starts contracting. The muscle starts contracting, and of course we know those are called labor contractions. Sometimes they call them false labor if they're a little early, but they're trying to push the baby out of the womb. Now, the contractions of the uterine muscle also send a message to a section of your brain called the hypothalamus. And the hypothalamus releases a hormone. And the hormone, hypothalamus being the control center, the hormone is released, and the hormone goes down to the uterus and makes the uterus contract even more. That is a positive feedback loop. It doesn't stop the contractions, it increases them so that eventually you force the newborn out of the womb. So that's an example of a positive feedback loop. You could look that up on your cell phones or whatever, and might have, if you have another question or two, you could find that out from that cell phone. So let's leave that principle there of homeostasis in negative and positive feedback, and let's go to page 25 and look at the, don't forget the quick check up there. How do negative feedbacks loops maintain homeostasis? Don't forget to read that. Circle them. Make sure you can answer those questions. Great questions to put on a test. Little short thing here about core principles. Structure and function are related. If you look down at the bottom, figure 1.15, and you see they're looking at the lungs, and you look over to the right in the first square, the first image from the person's body, you see the blood vessel, and you see a lung tissue, and you see the gases, oxygen and carbon dioxide basically, that can move easily over that very thin cell structure. Got a number of cells that are put together to make these little alveoli, they call them, little sacs where gas exchange occurs. And so it's a very thin membrane, easy for CO2 and oxygen to go across that membrane. And that's the way it should be. Get the oxygen in easily, get the CO2 out easily. But look over to the right. If the tissues become thickened, leave the alveoli, the little sacs, and go into the bloodstream, and CO2 come out of the bloodstream and back into the alveoli so you can exhale it. So you want to keep that lung system in good shape. Some of the kids that are doing the vaping, apparently, whatever they're doing, whatever substance they're vaping, is damaging tissue and creating at the least inflammation. But as they damage tissue, they could end up with something much more serious. So you want to take care of that very thin cell layer that allows you to bring in oxygen and put out CO2. So that's one way that structure and function are related. You wouldn't want that thin layer on your hand. You and I grab things sometimes that are pretty warm. We grab things that are rough. If you're working in the yard, you get your hands dirty and you can chafe them up pretty good. You don't want that down in your chest. You want a nice thick palm here to protect you, but you want that thin layer for gas exchange. So that takes care of that second principle. And as you look on page 26,